I put the timing on past reconstructions of environmental changes. The only way we may understand how the Earth is going to change in the future is by looking at the past. We can look at the past and see something that is similar to what we are seeing today. So if we are seeing parts of Greenland melting, and we are seeing that there is increased storm events in the North Atlantic on the east coast of the US, then we may actually be able to look at what is happening now and try to put that within a context and say, did this happen before? And if this happened before, what happened next? And knowing that is very important because we are seeing Greenland melting now. In the case of most of the cores I work on, it's what you may think of as mud. We call it sediment. It is ground up rocks, and you get little bit every, say, year or 100 years. And when we actually take these sediment cores from the bottom of the ocean, we actually can look at each layer, and we can know that the bottom layer was the oldest, and the top layer is the is closest to what we see today. And by looking at each layer, we can try to better understand the way that environment was responding to whatever was happening in our Earth. Okay, we see this chemistry, and that means that it was getting colder here. Sometimes you can feel it. You can actually touch it, and sometimes you'll see lots of small grains of sand like you would see at the beach, and then you'll see a bunch of rocks. And if you're in, say, the North Atlantic Ocean, that normally means that you had a lot of melting off of Greenland when you see lots of rocks, because it's bringing all the rocks from Greenland out into the middle of the ocean. This is just one example, but we can see it with dust from the Sahara Desert in Africa. So what we want to do is try to put all of those records together, all of this information we have, and the only way to link them is through time. We can say that we think something happened within a few thousand years, but that doesn't really apply to me today. If something happens in 3,000 years, if Greenland melted in 3,000 years, that doesn't matter. I want to know if it is going to melt in the next 100 years. By looking at specific records and archives, we can get a better understanding of just how quickly some of those things have happened. Because we can reconstruct temperature, we can reconstruct what kind of things are in the atmosphere, but it's not very useful if we don't know what time that actually happened. We want to know if something is going to happen very quickly. If Greenland starts melting, are we going to see calving of major icebergs and ice sheets every year? Or is that going to be a very gradual thing? Because that has a really big impact on what's going to happen to us. So specifically what I do is I do try to improve that resolution, and I try to improve the scale at which we can see things. So I spend a lot of time on a very small component, but when I get together with other scientists, I give them a tool to better understand what they're doing, and they give me tools to better understand what I'm doing, and together we put all of that together, and we can say we think we understand what the world looked like 20,000 years ago.